In this question, f of x is given, A matrix is given, and we need to find f of A. Just substitute the A matrix in the place of x. You'll get f of A is equal to A square minus 5A plus 6. First, we need to find the A square. It is 2, 0, 1, 2, 1, 3, 1 minus 1, 0 into the same 2, 0, 1, 2, 1, 3, 1 minus 1, 0. Is matrix multiplication possible? Yes, because it is also has 3 cross 3 order and 3 cross 3 order. Next, multiply this first row with first column, you'll get 4 plus 1, 5. Next, with second column, you'll get minus 1. Next, with this, 2. Next, second row with first column, 4, 2, 3, 9. Next, with this, 1 minus 3, minus 2. With this, 2 plus 3, 5. Next, 2 minus 2, 0. Next, minus 1. 1 minus 3, minus 2. Again, the order is also same, 3 cross 3. Now, in this, substitute this in this equation. Here 6 means it is 6i. I is nothing but the unit matrix of order 3 cross 3. When you substitute f of A square is 5 minus 1, 2, 9 minus 2, 5, 0 minus 1 minus 2. Minus 5a. Just multiply 5 with all the entries of this matrix. You'll get 10, 0, 5, 10, 5, 3, 15, 5 minus 5 and 0. Next, plus 6i. Multiply 6 with all the elements in the unit matrix. It is all the diagonal elements becomes 6. Now just add and subtract. Subtract and add the corresponding elements. You'll get the final answer. Next question. Prove this matrix multiplication is equal to 0, where theta and phi differ by odd multiple of pi by 2. First, let's multiply, because the order is 2 cross 2 and 2 cross 2, so matrix multiplication is possible. First, just multiply this. You'll get cos square theta cos phi plus cos theta sin theta cos phi sin phi. Next, with this, cos square theta cos phi sin phi plus cos theta sin theta sin square phi. Next, with second row, cos theta sin theta cos square phi plus sin square theta cos phi sin phi. Next, multiply with second column, you'll get cos theta sin theta cos phi sin phi plus sin square theta sin square phi. So what you should take common so that you can simplify this problem. This is cos square phi, right? Sorry. Now take cos theta cos phi common from the first entry. You'll get inside what will be remaining, cos theta cos phi plus sin theta sin phi, which is nothing but cos theta minus phi, because cos A minus B, so here theta is A and phi is B. You'll write it as cos theta cos phi plus sin theta sin phi. The same thing we are applying here, so it became cos theta minus phi. Similarly, take cos theta sin phi common. The same thing will remain inside. Here cos phi sin theta common. The same thing will remain. Here sin theta, sin phi common. The same thing will remain. So now take cos theta minus phi common from all the entries, because it is the same thing, right? Now what will be remaining inside is cos theta, cos phi, cos theta, sin phi, cos phi, sin theta, sin theta, sin phi. Now, in the question, here it's mentioned as theta and phi differ by odd multiple of pi by 2. What does it mean? It means theta minus 5 is equal to odd multiple, right? 2n plus 1 pi by 2. When you multiply cos on both sides, you'll get cos theta minus phi. Cos of odd multiple of pi by 2 is 0, right? Here n can be anything from 1 to 2, 3, so on. So now 0 into some matrix will always be 0, hence proved. Matrix A is given and we need to show that this satisfies. So first, let us assume tan alpha by 2 as x. Just to simplify our problem, let x will be the tan alpha by 2. Now, actually from trigonometry, we can write cos alpha in terms of tan alpha by 2. How? It is 1 minus tan square alpha by 2 by 1 plus tan square alpha by 2. Now what it means? Just in place of tan alpha by 2, write x. You'll get it as 1 minus x square by 1 plus x square. Similarly, write sin alpha in terms of tan alpha by 2. You'll get as 2 tan alpha by 2 by 1 plus tan square alpha by 2, which is 2x by 1 plus x square. Now solve the LHS. In the LHS it is given as I plus A. Identity matrix of order 2 cross 2 plus the given matrix, which is 0 minus tan alpha by 2, tan alpha by 2 and 0. Now it is 1 x 1, sorry, minus x. In place of tan alpha by 2, I'm writing it as x. Now solve RHS. It is I minus A into, write cos alpha in terms of this, you'll get it as 1 minus x square by 1 plus x square minus 2x by 1 plus x square. This is 2x by 1 plus x square and 1 minus x square by 1 plus x square. What is I minus A? It is 1 x minus x and 1. You can solve and just verify it. It is again the same 1 minus x square by 1 plus x square minus 2x by 1 plus x square, 2x by 1 plus x square, 1 minus x square by 1 plus x square. Now matrix multiplication. Now matrix multiplication is possible. Just multiply with the first row with first column. We'll get it as 1 minus x square by 1 plus x square plus 2x square by 1 plus x square. Now with second column, minus 2x by 1 plus x square plus x minus x cube by 1 plus x square. Now multiply second row, minus x plus x cube by 1 plus x square plus 2x by 1 plus x square, and next 2x square 1 plus x square plus 1 minus x square by 1 plus x square. Now just take LCM and solve it. You'll get here 1 plus x square by 1 plus x square 1, and next here now minus 2x plus x becomes minus x cube, right? From here minus 2x plus x becomes minus x, and remaining is minus x cube. Now take minus x common. Inside 1 plus x square will remain. Just cancel with that. You'll remain with minus x. Similarly here minus x plus 2x, it becomes x cube plus x. Take x common and cancel with the denominator. X will remain. Here 1 plus x 1 minus 1 plus x square by 1 plus x square 1 will remain. Now just compare with LHS. Is it equal? Yes. So LHS is equal to RHS, hence proof.